Hello students, today we're going to look at degenerate conics. Last class we saw how an equation in the form ax squared plus cy squared plus dx plus ey plus f equals 0 usually led to the graph of a conic section. But this is not always the case. Sometimes we'll get something that's kind of weird seeming. This is called a degenerate conic. And I want to talk about the possible things that can happen. So we're going to look at a few different examples to see what the possibilities are. Sketch a graph of 9x squared minus y squared plus 18x minus 6y equals 0. First, I'm going to rearrange the terms so that we can go through the process of completing the squares. We've got 9x squared plus 18x, and then minus y squared minus 6y equals 0. Now for completing the squares, remember we always need to factor out that leading coefficient. So we're going to have 9 times the quantity x squared plus 2x. I'm going to leave a space to complete the square. And then we're going to factor out a negative 1. Or a subtraction, and that's going to leave us with x squared plus 6y. It's going to be positive 6y because we factored out that negative, and all of that equals 0. Now, to complete the squares, on the inside of the first one, to complete this first square, we need to add 1. But what we're really adding is 9 times 1. We're adding 9. So on the other side, we have to add 9 to counterbalance that. And then over here, to complete the square, we need to add 9. But what we've really done is we have added negative 9 because that's being subtracted. And so to balance our equation, we need to add negative 9 or subtract 9 on the right-hand side. And these 9s actually end up canceling out. So when we go through and we factor these, we get 9 times x plus 1 squared minus the quantity y plus 3 squared equals 0. Now this looks kind of like a hyperbola because we've got a positive term with the x squared and we've got a negative with the y squared. But there's a problem, and the problem is that our constant term is 0. Remember that when we have a hyperbola, we want to divide so that we end up getting 1 on the right-hand side to put it in the right form. But we can't do that here because there's no constant term at all. So this is what we mean by a degenerate conic. It's not quite fulfilling all of the requirements. We do have the x squared and y squared terms, but we don't have a constant term, so we can't get this into the right form. However, we can still figure out what the graph is going to be. It's just going to require a little bit of creativity. So I'm going to move this y plus 3 squared to the other side to make it positive. This gives us 9 times x plus 1 squared equals y plus 3 squared. And I'm actually going to switch the two sides because it's going to be easier to have the y on the left. So y plus 3 squared equals 9 times x plus 1 squared. And what we're going to do is we're going to try and solve for y. And to do that, we need to get rid of the squared, and so we can use the square root property. So when we take the square root of the left, we get y plus 3. And then on the right, when we take the square root of 9, we get 3. And the square root of x plus 1 squared is just x plus 1. But remember that when we take the square root of both sides of an equation, the square root property says we need a plus or minus. So I'm going to put the plus or minus there. And then we're going to go through and figure out what these are going to be, because we've got two equations now, one with a plus and one with a minus. So let's actually look at these two separately. Y plus 3 is equal to positive 3 times x plus 1. Or y plus 3 is equal to negative 3 times x plus 1. If we distribute the 3 in the first equation, this gives us y plus 3 equals 3x plus 3. And if we subtract 3 from both sides, This gives us y equals 3x. Now for the other one, if we distribute the negative 3, we get y plus 3 equals negative 3x minus 3. And if we subtract 3 from both sides, we get y equals negative 3x minus 6. And so our solution is actually going to consist of two different lines. Let's actually go through and plot these lines. Y equals 3x is a line that has y-intercept 0 and slope 3. So it's going to look something like this. And then the other one, y equals negative 3x minus 6, this is going to have a y-intercept of negative 6, and then a slope of negative 3. It's going to go down 3 into the right one, or up 3 into the left one. So it's going to be moving in this direction. Now I know it seems weird that our graph ends up being two lines, but remember, when we had a regular hyperbola, we started off by drawing two lines that the hyperbola was asymptotic to, and we had kind of that central box that we would start drawing from to get closer and closer to those lines. Because we have this 0 here, effectively what it means is that the central box has no area. It's just the actual point in the middle, and so instead of being asymptotic to those lines, it's just going to be on those lines. So degenerate conics, there's a relationship, a loose relationship to the conic section that it comes from, but weird things happen. We don't actually get conic sections. We get something that's very much tangential, pun intended, to conic sections. So in this case, we have a degenerate hyperbola, and in this case, the graph is two lines. We're going to look at a couple more examples in the next video so that you can see the other possibilities, because it's not just going to be two lines. There are other ways that we can get different graphs.